The presentation will be about validation techniques. It's important to start with the context. So what's the problem? Everyone knows about administrative data. I mean, people have to fill in forms, and particularly businesses. They have to fill in forms on an annual basis, on a monthly basis, on a trimestral basis, many forms. So that could be called big administrative data. So it's an enormous burden, it's an enormous load for businesses. And there are many data users. When you fill in a form, tax data, social data, it's used by several kinds of social security agencies, use data. So many data users. As these forms are particularly complex, there might be hundreds of fields in difference in a social form. So it's essential to define a format, to define more generally an interchange standard. So every form has to comply with a certain standard, which means that we might say that XML schemas are perfect for that purpose. It's just a part of the structure of our social form, our déclaration sociale nominative. So we have a tree structure with data about establishments, about firms, about individuals, about contracts, etc. So we have that kind of structure. In fact, XML schemas to describe a form are not enough, because you are obliged to describe the consistencies. There are a certain number of rules of consistency between the different fields, between the different data. For example, you can't be fired before you're hired. So the starting time is lower than the ending time. Another example, in a form, you have information about the employees of the firm. All the employees' ID have to be different from each other. And if not, it's a way to detect fraud. Another idea, in some cases there is no social security idea, but some temporary idea. So a rule can be, if social security ID is not present, then the temporary ID has to be present. More generally, if you want to describe precisely the interchange standard, you need to have a grammar to describe mathematical expressions, I mean the consistency rules. So we need a domain-specific language, a DSL. So it requires more, to do that, it requires more than the XML schemas. But the main problem the main problem I have in my job is that the standard change over time. I mean, the legislation, I mean, politics are very creative. They always have ideas, and the legislation can change every day, every month, especially in France. Data users have new needs. They want new data. So we have approximately 1,000 change requirements per year. 1,000 changes in a standard. It's enormous. It's really enormous. So
it's not only on the one step. Each day there are new change.
And so it's not presented to be read, but here it's the 717th line of an Excel file with the changes we've been asked for. So it's a lot of work, and the fact that the standard changes over time means that we have to standardize standards. And the idea is to have very general tools, and so we have to jump a level of abstraction and say, okay, what is an interchange standard? What is it exactly? It's a list of data blocks. I mean, you have data, they are in blocks. so the word we use. The message has to have a tree structure. Okay. For each block, you have a list of data. But for each data, you must know its nature, numerical, alphanumerical, etc. The regular expression that describes it, whether it's compulsory or not, the minimum, maximum length, and of course, you need a list of consistency rules because you have rules between the data. So in the case of social forms, we are on very, very large scale standard. It's, I told that before, hundreds of fields, so it's a lot.
Imagine that every company in France have to send this declaration to your organism to manage this. So it's perhaps all the French go to every month in this system.
So for this reason, we need a meta level. We need another level of abstraction to describe a standard in general. So that's why in our approach, EMF was needed. So that's not just an example of the tree structure of the data. I mean, it's exactly what we have, the tree structure of the Déclaration sociale nominative, the new Déclaration sociale nominative in France, with all the blocks of data. If you unfold each block, you have all the data with it's approximately 200. So what tools? Because this work is the work between CNAV and OBO. OBO did the development. So we didn't need tool to validate data. We needed tool to generate tools that validate data. Why? Because the standard changes over time. So first of all, we need a tool which is called the designer. Designer is a tool to define any kind of interchange standard. So a DSL was defined, and it gives a kind of common language between the different actors. And it's used in practice on Déclaration sociale nominative. So
any kind is very important because that's why we are here today. That's the thing that could be used in other domains.
If it was not that general, it would have no interest. Of course, you have to validate declaration forms. Okay, it's very common. The general aspect is more interesting. It's not so readable. So in the designer, you can define a block of data. Here, the establishment. You can define a data which is characteristic. So here, the name. Can have a validation rule here for the birth date. Because there are some specific things in France. If you are born in Corsica before 1976 or after 1976, it makes differences. You can define data type, maximum length, minimum length, nature, etc. So you can define all that with the designer. So then the question is, okay, we can define a standard, an interchange standard. So what? What's the use? First use, it provides an automatic generation of the documentation of the standard. So in practice, it's used for Déclaration sociale nominative, and this documentation is on the website of the DSN. And so we generate, so here is the block emitter and with the different data and the comments and the validation rules, etc. So it's an extract. These documentations may be 250 pages or something like that. So it's automatically generated. So what? If it was only used for documentation purpose, it wouldn't be that useful. Interesting, but not that useful. The main thing is that we generate automatically the data validation component. So more precisely, the designer generates a knowledge base. In fact, the knowledge base, it's a Java archive. It's a jar. And we have another tool, generic tool, which is called the validator. It's a kind of an engine. validation engine which reads the knowledge base. And so the validator doesn't know anything about social forms. Doesn't know. Doesn't exist for him. The knowledge base contains all the information about social forms. So validator plus knowledge base give the data validation components and that kind of thing, this jar. So in fact, these components, there are 4 steps. Conversion into XML, syntactical or syntactic validation, semantic validation, and then a report with all the errors found. So conversion, you have a flat file with the name of the variable, so the value, and then translation into XML. Syntactical validation, you check the data type. Is it okay in terms of length, in terms of compulsory or not nature, etc. And then the semantic validation, that's this Java code, but this Java code was generated using a DSL. So it's an example of a validation rule, which is written in French here. It's written in a mathematical formula. I mean, it's first order logic formula. So it's a very simple DSL formula, and then we generate the Java code. So
for the
okay.
I will speak now. So for the technical requirement, as you understand, we have to work on very large models. So for example, the models that we use are more than 500 megabytes of EMM model. I don't know if lots of persons already work with this kind of very, very large file. And we have lots of this kind of file. We need also to sustain a high throughput. So it's when we start, you will succeed to do this kind of validation only 1 time per month. The goal now is to go very quickly, perhaps in each day, something like this. So we need to go very fast and to scale out. And third, we want to be able, say, to express complex rules without the need to be a developer. So if you need for each rules to develop, it will fail because there are too much new rules every day. Usually when you have new rules, you only have several days or perhaps 1 2 days.
Less than 1 day. Just quickly to give an example, a few months ago we had a phone call. It was maybe 4 o'clock in the afternoon, and they wanted to have the new validation components using new rules. They said, ideally, it would, if it was possible tonight, it would be perfect. But I mean, tomorrow morning maximum. And the truth is that the next morning, exceptionally, it was the only time in the year. There was no one in my team. One was on a holiday. The other one has a training or something like that, just for the morning. And then. At 9 o'clock, I had a phone call. We really need that, and at 10 o'clock, it came to the let's say the CEO. I mean the head of the CNAV, my agency, and it was a real problem not to have the validation component in the morning. So now I make sure that every day, every day of the year, someone of my team is here to answer quickly. So that's why we need this kind of approach, because we need to modify, to add quickly a validation rule, to add quickly data, to change the structure very quickly, to generate automatically tests, etc., and to generate the validation component.
It's like a customer take 2 years to define if he wants or not, but when he says yes, I want it, tomorrow I want it.
Yes, something like that. Yeah.
So as we see this afternoon at the keynote, we make several tests and we fail. First one, we try with XSLT XPath, but the use of DOM doesn't scale. just impossible with 1 terabyte to load everything. Secondly, we go to streaming accessibility, to go with a stream, and it's failed too because creates the rules with accessibility was just a nightmare. Third, we try with list storage and list and LRU strategy, but you know it's the kind of lazy loading of the last used file of the systems, but it was not enough with enough good performance, so it failed too. So the real strategy that we use is to create our own validation engine, and we take a requirement that the language, the DSL has to be tree-oriented. It's not a graph. It's really a tree with containment. Third, there is an E-class that can be responsive and signal other E-class. So it cannot work in any kind of graph today. And rules need to be expressed in DSLs.
So it's important that it's in first order logic because sometimes the rules can be very complex. An example I took before was all the employees have different ideas, have different identifiers. So it requires quantifiers. So first order logic.
So the principle. We read the document in depth first order, okay? And for each element, we find which rules can be concerned by these rules. And as soon as we can, we unload the kind of element of the models. We will not be reused anymore. And you can see after the kind of schema, we will explain this in line. Let's see. You have first rules in blue, second one, another one. They register themselves to the graph to say the rules one is concerned by these two ones. So when we load the graph, when we write this, we will load some other part. So this one need to be read by these rules. This one also by the second rules. But when we finish to execute the blue rules, we will unload just this part. So by doing this, on a pure performance aspect, it could be not so efficient, but it's a good way to scale very well, and it's needed to do a kind of pre-processing of each rules to know before the execution on which part of the model they will be executed. So it's something really strange. It's you analyze the rules, you target on which part of the graph you will be executed, and you connect this as an event engine on this part.
Because the problem is that data are not in databases. They are in a flow. They are in a message, and you read them. So you have to use this kind of techniques.
And so you have the business model with something which is human readable. We generate an e-core meta-model at this point to have a good efficiency, which is just unique for each new version of your rules. And we generate code, directly Java code, and it's not the EMF Java code, of course. It's really dedicated for validations to be sure that everything will go very, very fast for these rules and these data.
The important thing is one important thing is on the left. The rules have to be written by people who are not computer scientists and that know social data. But I mean, in the middle run, my aim is that I won't need computer scientists in my team, just specialists of the social data.
Let's have a look very quickly at the kind of real rules that we have to work with. So as I explained, we pass the first time all the rules. We see that we will work on this data, so we subscribe to this, and after we do the graph lazy cast as expected.
So we use quantifier as every, we use predicate as is present, we use a function like substring or etc. And obviously logical connectors and or etc.
So here, it's a very nice and interesting result. You can see in blue the performance of the first version based on the accessibility of the engine. And you can see in red the performance of the new one.
So it's not a mistake.
No, it's not a mistake. So, like, let's zoom. And here you can see it's a logarithm plot. So when this takes several days of computation to manage several gigabytes of file, now it's just several minutes. So the performance is very just amazing, and it changes the way as you say, you give us some feedback to your internal customer. So the performance for small file it works well, but for large file it's just very good because its performance are linear. It's just
linear function of the size, in fact.
Yeah.
So.
It's function.
But a few years ago, we had failed. It was not linear, and I can assure you that when it's not linear, it's a real problem. You can't work with it. So larger than 1 gigabyte, but it could be more.
Just some information for those we already see some algorithms on EMF compared to the kind of same algorithm are being used in the two projects.
So what else? We showed that with this technique we can automatically generate a documentation of the standard, and we can automatically generate a validation component. This validation component, data validation component, is used in a production environment. It's integrated in a production environment. But we also generate a local validation tool using a general graphical user interface. The idea is that we have, in fact, a general graphical user interface that is based on the meta model of the standard, totally independent from any interchange standard, but based on the meta model, to display information on errors in the form, in the declaration. So practically, the general graphical user interface plus the validation engine plus the knowledge base makes the local validation tool. So how does it look? In practice, on the left window, you have all the errors, and you can display information on the errors. In the middle, you have all the characteristics of the standard. You can, I mean, it's a way of looking at the documentation, and you have all the information about that. And here you have the contents of the form itself, what you sent, what you declared. And here you would have the values. So you have all the necessary explanation to understand why what you declared was wrong in a way or another. And it's very useful because suppose you are a business, you send your form and you receive a message from the administration saying you have hundreds of errors, etc. You prefer to do that yourself and to see that there are many mistakes, to try to understand that yourself before sending it to the administration. Well, so in practice, it really works, which means that the DSN form, DSN means Déclaration Sociale Nominative. It's a new way for the French firms to declare social data, to send social data, and it will replace all the forms sent by all the social forms sent by the enterprises. So it's a very important way of simplifying things for businesses. So the DSN forms are really handled using our data validation component. It's and we have a local validation tool I just showed you, which is named DSN Val. It's available. It's possible to upload it on the DSN website. So it also works. And just to end this presentation. So what can we say in a few words about that?
I can just say something. It's first thanks to a guy which is a technical leader of this project who is not here, but I would like just to say to give you the name of the guy. It's Romain Guider, and he just we do lots of brainstorming to think about the solution on this. And this guy was great before, he was a Nobel guy. He worked at Sun on the JALAC compiler, and he worked a lot on language compiler, and all these solutions come from this kind of same algorithm, how to compile to bytecode with a very large scale models which are the language itself. And you apply this kind of thing here. So it's quite interesting to see how we can imagine very different can target this kind of thing.
So just to end this presentation, to summarize it in a few words, what was it about? It was about administrative data in general, but not administrative data themselves, but the sending of administrative data, filling in forms and sending it to the administration, and checking the validity of the data. So what we've built, CNAV and OBO, we've built a software suite for interchange standard in general. In this software suite, we have the designer, the validator, the general graphical user interface. There are other projects we will in the future automatically generate test cases or things like that. So a very general software suite that could be, as Etienne said, that could be applied in other domains. Now it works for social security purpose, but as long as we keep the same meta model, it could be used for other purposes. Perfect. It can be generalized to any kind of businesses' social forms, and I can't answer if it will be open source one day or another, because we in the public sector, I have to discuss with my administration, etc. But let's say I wouldn't write it, but I hope that it could be open source. Let's say later 2015, so next year.
Eventually to discuss about this. If you're interested, please speak with Pascal. Some argument to say that could have some interest.
Well, thank you.
Thank you.